Third International Physics Olympiad, year 1968, IPHO. Problem number 1. Figure shows a mechanical system consisting of 3 carts A, B, and C, of masses M1 equal 0.3 kg, M2 equal 0.2 kg, and M3 equal 1.5 kg respectively. Carts A and B are connected by a light taut inelastic string which passes over a light smooth pulley attached to the cart C as shown. For this problem, all resistive and frictional forces may be ignored, as may the moments of inertia of the pulley and other ends of the wheels of all 3 carts. Take the acceleration due to gravity G equal to be 9.81 meters per second square. First question. A horizontal force F is now applied to cart C as shown. The size of F is such that cart A and B remain at rest relative to cart C. A. Find the tension in the string connecting carts A and B. B. Determine the magnitude of F. Part 2. Later, cart C is held horizontally while cart A and B are released from rest. A. Determine the accelerations of carts A and B. B. Calculate all the tensions in the string. Third International Physics Olympiad, year 1969, IPHO. Problem number 2. Water of mass M2 is contained in a Cooper calorimeter of mass M1. Their common temperature is T2. A piece of ice of mass M3 and the temperature T3 less than 0 degrees Celsius is dropped into the calorimeter. Question A. Determine the temperature and the masses of water and ice in the equilibrium state for general values of M1, M2, M3, T2, and T3. Write equilibrium equations for all possible processes which have to be considered. Question B. Find the final temperature and the final masses of water and ice for M1 equal 1 kg, M2 equal 1 kg, M3 equal 2 kg, T2 equal 10 degrees Celsius, T3 equal negative 20 degrees Celsius. Neglect the energy losses. Assume the normal barometrical pressure. Specific heat of Cooper is C1 equal 0.1 kilocalorie per kilogram 1 degrees Celsius. Specific heat of water C2 equal 1 kilocalorie per kilogram by 1 degrees Celsius, and the specific heat of ice is C3 equal 0.462 kilocalorie per kilogram by 1 degrees Celsius. Latent heat of fusion of ice L equal 78.7 kilocalorie per kilogram, and take 1 calorie equal 4.2 joules. Third International Physics Olympiad, year 1969, IPHO. Problem number 3. A small charged ball of mass M and the charge Q is suspended from the highest point of a ring of radius R by means of an insulating cord of a negligible mass. The ring is made of a rigid wire of a negligible cross-section and lies in a vertical plane. On the ring there is a uniformly distributed charge big Q of the same sign as small q. Determine the length L of the cord so as the equilibrium position of the ball lies on the symmetry axis perpendicular to the plane of the ring. Find the first general solution for particular values. Big Q equals small q equal 9.0 multiplied by 10 power negative 8 coulombs, R equal 5 centimeters, M equal 1 gram, epsilon 0 equal 8.9 multiplied by 10 power negative 12 farads per meter. Third International Physics Olympiad, year 1969, IPHO. Problem number 4. A glass plate is placed above a glass cube of 2 cm edges in such a way that there remains a thin air layer between them. See the figure. Electromagnetic radiation of a wavelength between 400 nanometers and 1150 nanometers, for which the plate is penetrable, indicate perpendicular to the plate from above is reflected from both air surfaces and interferes. In this range, only two wavelengths give maximum reinforcements. One of them is lambda equal 400 nanometers. Find the second wavelength. Determine how it is necessary to warm up the cube so as it would touch the plate. The coefficient of linear thermal expansion is alpha equal 8.0 by 10 power negative 6 negative degrees Celsius. Interactive index of the air N is 1. The distance of the bottom of the tube from the plate does not change during warming up.